Namaste and welcome to another video on the geometric part of mathematics, that is circle. In this video, I'm going to explain one of the theorems of a circle, that is alternate segment theorem. So let us start with the statement of the theorem. The theorem says the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. This is how the diagram will look like. There is a chord and a tangent. The chord is meeting the tangent at point of contact, and the theorem says the angle between chord and tangent is equal to the angle in alternate segment. Now here it is important to learn what is the meaning of alternate segment. So whenever a chord is drawn in a circle, the circle is divided into two segments. As you can see, the yellow colored and green colored segments are the two segments formed by the chord AB. And you can also see that there are two angles formed between chord and the tangent. One is angle BAT and the other one is angle BAP. Now for the angle BAT, as you can see, that angle includes the right hand side segment of the circle. So for this angle, the other part of the circle, that is the left hand side segment of the circle, is known as alternate segment for angle BAT. And according to the theorem, any angle in this alternate segment formed by the chord, that is joining the endpoints of a chord to any point on this segment, will be equal to angle BAT. So if we draw one of such angle, it will look like this, angle BCA. So according to alternate segment theorem, angle BAT is equal to angle BCA. Now if we talk about another angle formed between the chord and the tangent, that is angle BAP, then this angle covers the left hand side segment of the circle, that is the major segment of the circle. So for this angle BAP, the other segment which is on the right hand side, which is on the opposite side of that angle, the green shaded segment, this segment is alternate segment for angle BAP. So any angle in this segment will be equal to angle BAP. So angle BDA is the angle in alternate segment for angle BAP, and it will be equal to angle BAP. So this is the alternate segment theorem for a circle. Let us see the proof of this theorem. For the proof, we need to draw a diameter AE and join the points EB. Now if we see this, diagram, the angle formed between diameter and the tangent, we can also say the angle between radius and tangent at point of contact, that is always 90 degrees. So suppose if this part inside is x, then the angle formed between chord and tangent, angle BAT, will be 90 minus x. Then if you see in this triangle AEAB, angle EBA is the angle formed by the diameter, so that will be 90 degrees. By using angle sum property of a triangle, one angle is x, another angle is 90 degree. So the third angle will be 180 degrees minus the sum of other two, that is 90 plus x. So that will be 180 minus 90 minus x, that is 90 minus x. So angle BEA will be 90 minus x. And angle BEA or angle BCA, they are the angles in the same segment. So any angle formed in this part of the circle will be equal to 90 minus x. So thus the angle between chord and a tangent is equal to the angle in the alternate segment. If we see the another angle, that is angle BAP, it forms a linear pair with angle BAT. So suppose if angle BAT is x, angle BAP will be 180 degrees minus x. And if you see inside the circle, as per our previous proof, angle BCA will be equal to x, that is this angle in the alternate segment, and angle D is the opposite angle of a cyclic quadrilateral. And we know from our previous theorems that opposite angles of a cyclic quadrilateral are supplementary. So if this angle is x, angle BDA will be 180 degrees minus x, and thus angle BAP 180 degrees minus x is equals to angle BDA, that is also 180 degrees minus x. Hence, the angle between tangent and chord through the point of contact is equal to the angle in the alternate segment. Now let us see one question, the solved example based on this theorem. The question says, in the figure, O is the center of circle and PQ is the tangent to the circle at point A. Angle PAB is 58 degrees. We have to find angle ABQ and angle AQB. We need to find these two angles. Now if we see here, the angle 58 degrees is the angle between tangent and the chord. So as per the alternate segment theorem, angle 58 degrees, which is covering the left hand side segment of the circle. So 58 degrees will be equal to any angle formed on the right hand side segment of the circle with the same chord AB. And you can see AB is forming an angle at point R. So angle ARB is equal to 58 degrees by the theorem of alternate segment. And then when we know that BR is a diameter, angle BAR will be 90 degrees, and then we can find angle ABQ by angle sum property, that is 180 degrees minus the sum of other two angles. So that will be 180 degrees minus 148 degrees, that is equals to 32 degrees. So we got our first answer, angle ABQ equals to 32 degrees. We have to find another angle AQB. Now that AQB angle can also be found with the help of alternate segment theorem. This angle ABQ or angle ABR is the angle formed by the chord AR. And this chord is making angle with the tangent PQ. So as per the alternate segment theorem, angle RAQ is also equals to 32 degrees. We got this angle as 58 degrees. So angle AQB can be found out. Angle AQB is equal to 58 degrees minus 32 degrees by the property of exterior angle of a triangle. If we see this small triangle AQR, then 58-degree angle is the exterior angle for the triangle, which is equal to the sum of opposite interior angles, the sum of these two angles. From this, we know this is 32 degrees, so we can find the other angle by 58 degrees minus 32 degrees, and that is 26 degrees. So our second answer, angle AQB, is 26 degrees. I hope you have understood the alternate segment theorem, and you can practice few more questions on your own. Thank you for learning.